Okay, so we were looking up the solubility of ammonium sulfide. So I would look for ammonium in either of these columns, and there it is. It says that it's an ion that forms a soluble compound, and there are no exceptions. So whenever it has ammonium, it's going to be soluble, which means it'll be aqueous. So I'll write AQ. All right, and then we look up ammonium phosphate. Well, remember we just saw that ammonium is always soluble. It never has an exception, so I know that this is going to be soluble as well. And then lastly, I have CdS, so cadmium sulfide. If I look for cadmium here, I don't see it, but here is sulfide, and it says that it normally forms an insoluble compound unless it's with an alkali metal or NH4. It's not with either of those things, so it's not an exception, so it's going to do what it normally does, which is form an insoluble compound. So that's going to be a solid. Okay, so now we need to determine the reaction type and whether or not the reaction occurs. So I have a compound plus a compound produces a compound plus a compound. Remember, it's a compound because it has more than one type of atom in it. So when I have compound plus compound produces compound plus compound, that's a double replacement reaction. And then to determine if that reaction happens, let's look at these notes again. For double replacement reactions, if both products are aqueous, the reaction does not occur. Every other reaction occurs. Okay, so let's look at these products. We have aqueous and solid. So they're not both aqueous, so that means yes, that reaction does occur. Okay, and the last thing to do here is to balance this guy. So I'm going to make my chart of reactants and products. I have CD, PO4, NH4, and sulfur. Okay, and so on my reactant side, I have 3 cadmiums, 2 phosphates, 2 ammonium, and 1 sulfur. On my product side, I have 3 NH4, 1 phosphate, 1 cadmium, and 1 sulfur. Okay, so let's balance the cadmiums first. I've got 3 here, so let's put a coefficient of 3 right here. That'll change this to a 3 and this to a 3. Let's just go on down the line. I have 2 phosphates here and just 1 here. So let's put a 2 right here. That'll give me now 6 ammonium on this side and 2 phosphates. Okay, so let's go to ammonium. I have 6 over here. So to get 6 on this side, I need a coefficient of 3. That changes this to 6, and then it makes me have 3 sulfides. So perfect, I am balanced now, and so this is my correct balanced equation.